Welcome to the second part of the Minimal Interoperability Mechanisms e-learning module. First, how can a city or region use the MIMs in practice? Let's explore how the MIMs can be applied. This is Pablo. He is leading the Smart City office in his city. He would like to develop a local data space on smart energy and potentially scaling it up at regional or cross-border level in the future. Data spaces, intended as an infrastructure that enables data transactions between different data ecosystem parties. Based on a defined governance framework, Pablo's data space will aim at bringing together a variety of energy-related data such as energy consumption, grid use data, or the use of renewable energy. This data is shared in a harmonized manner, while ensuring data safety and privacy. Pablo's project engages a multitude of stakeholders required to collaborate, the collection of vast data sets from several organizations such as energy suppliers and grid operators, thus necessitating effective data management. Pablo seeks guidance from the MIMs to kickstart the creation of his city's data space. He is looking for best practices to build an effective and secure data management approach and IT infrastructure for his project. Let's embark on Pablo's journey into data management and the MIMs. Let's have a look at how can MIM 1 support Pablo in the management of context data within his local data space. To have a deeper understanding of the city's situation in terms of energy consumption, Pablo is wondering how context data should be collected and managed to provide more insights to decision-makers and urban planners. In urban planning, context data about population density and environmental factors can inform decisions about where to build new energy infrastructure and improve efficiency in energy distribution systems. By collecting data about user behavior, preferences, and context such as location or time of day, smart cities can offer services and resources that are more relevant and valuable to their residents. MIM1 can guide Pablo to manage the context information coming from Internet of Things devices and other public and private data sources, if possible, through a uniform interface. To have a better view on his city's energy consumption in both public and private buildings, Pablo would like to access the data on thermal and energy storage, collected by captors in multiple energy systems, and be able to access it through a dedicated platform. Indeed, MIM1 recommend that applications should be able to access data from different cities and communities. Applications should be able to use both current and historical data, use geospatial querying, and be automatically updated when the source data changes, and applications should be able to discover and retrieve data relevant to their context from a variety of sources, including from within larger datasets and with default limits and page sizes. C3 Requirements. To implement this last capability, Pablo should ensure that relevant data sources on energy consumption and production in his city shall be discoverable and retrievable, at least for location and time period. In addition, specific subsets of data relevant to this context shall be retrievable from within larger datasets, using default limits and page sizes. After checking the requirements of MIM1 on context data, let's now have a look at how can MIM2 support the adoption of data models in Pablo Energy data space. To better manage and share data with and within its data space, Pablo would like to adopt smart data models on energy data. Data models are serving as a language in which systems can talk to each other, ensuring data integrity and preventing data anomalies. Indeed, clearly defined data models can help cities in choosing and opening up data across solutions. MIM2 can guide Pablo on his quest to adopt data models, as it includes guidelines and a catalog of minimum common data models. To do so, MIM2 envisions a harmonized representation formats and semantics that will be used by applications to consume and to publish data. MIM2 recommends that all entities included in datasets relevant for Pablo's city should be described using consistent data models to enable interoperability for applications and systems, and that these data models should be machine-readable and handled by the context management APIs. Finally, all datasets in this data ecosystem should use consistent identifiers for individual instances of each entity. To ensure consistency, data models used for all entities in any energy datasets in Pablo's city shall be made explicit. Moreover, data models should as far as possible be taken from a commonly recognized set. of standardized data models so that translation engines can help align data models coming from different sources within a city community data ecosystem, where it is not possible to precisely align data models. Standard concepts and vocabularies should be used to enable a good enough level of consistency between them. If new data models are needed due to the unavailability of a standardized data model, they shall be clearly defined using a consistent and explicit process to enable ease of transformation between the different sets of standard data models. For further guidance on data models, Pablo could check the website smartdatamodels.org and the SEMIC Style Guide. Pablo is now well equipped to adopt data models. He is now wondering how MIM4 can assist him in protecting data privacy. Finally, Pablo is wondering how personal data should be handled to ensure security, trust, and privacy in accordance with the relevant legislation in place. Furthermore, data holders in the city shall take the necessary security measures to ensure that personal data is protected and not subject to any unauthorized disclosure. MIM4 can provide recommendations to Pablo regarding citizens' data protection rights and needs to better understand the management of their data. Citizens should have insights on how their personal data is used, stored, or shared by the providers of the applications and/or services they use. They should also have confidence that data about them is processed appropriately to manage privacy and to a high degree of security. Moreover, citizens should be able to request changes to or deletion of part or all personal data available, stored, shared, etc. by the providers of the applications and/or services, as well as choose the operator they wish to manage their data, to move from operator to operator and access their data through different channels. In particular, Pablo and other data holders shall ensure that the data is documented and discoverable, use standard data models to list their available datasets, and use an open application programming interface to enable personal data intermediaries to discover and broker data. In addition, personal data intermediaries should make use of that common API. Pablo is now familiar with some of the requirements of the MIMs, corresponding to the challenges he had identified and was seeking guidance to tackle. In the future, he will be able to refer to the other MIMs to foster the interoperability of his local data space. You can find more information on the MIMs on the OASC website. European cities and regions can join a network of smart cities such as Living in EU and the European Digital Infrastructure Consortium. If you are interested in interoperability, please also check the NIFO collection on JoinUp, where many resources on this topic can be found. If you enjoyed this e-learning module, please find here a second e-learning module focused on the European Interoperability Framework for Smart Cities and Communities. Thank you for watching.